questions from you guys. So we can treat this as, kind of like a test review day. You guys can ask questions about any previous homework assignments or the test review or any kind of thing like that might be still something that's a little foggy for you. The goal here today is to just kind of clean up some of those areas that we feel uncertain about. Because when is the test? Tuesday, right? Monday's a B day. So Tuesday's an A day. Okay? So just kind of keep that in mind as we're doing things. So we can spend kind of as much time as we need to here answering questions. And then if we finish, we can always start talking about the next set of topics for Chapter 2. But if you guys have questions, we can just keep doing questions. And that's kind of what I blocked off today to do. Because I think this time is important. You've had a chance now to probably try, most of, if not all of the homework, and should have places where it's like, boy, that part didn't go well or did go well, or I want to talk about this idea, or I'm not sure when to do this, or any kinds of questions like that. This is a great time to kind of help get things straightened out. So when it comes time to actually sit down and study, you feel a little bit more confident that you're doing the right things and you know what to do and that sort of thing. So if you need to take out a tablet to look at your previous homework assignments to see where you have questions, or if you know what you're going to ask questions about, you're welcome to do that sort of thing. Whatever makes life easier for you. If you reference a specific problem, I'll put the specific problem here on the board and we'll do it together and kind of talk our way through it. And I'll explain kind of what I'm looking at or what I'm looking for, what I'm doing while I'm doing it. Okay? Sound fair to you guys? Okay. So, what do you guys want to talk about first? The floor is yours. Joe.
Can you go over homework 3, number 2? We'll get more.
Yeah, sure. Okay. So we'll start here by looking at doing the domain and range part first. So the domain is about the x-coordinate. So to start the domain, what I'm going to look for is the point that's furthest on the left. That would be this point, -6, -3. And then I'd want to locate the point that's furthest to the right. That would be this point that's 6, 0. And then I want to check to make sure that the graph is kind of connected in between them, which in this case it is. So the domain that I'm going to write, the lower bound is -6, and the upper bound is +6. And because the -6, 3 is a point on my graph, there is a point on my graph that uses that x-coordinate of -6. I know I should use a bracket there. And because +6 also is used by a point in my graph, I should use a bracket there. Are we okay with that part? Okay. Now to do the range is about the y-coordinate. So I'm going to start by locating the lowest point on my graph, which is 2, -4. And then the highest point on my graph, which is 5, 0.5. And I notice that again, I want to check to make sure the graph is connected between those 2 points, which it is. So I can do this just using one interval. So the y-coordinate, the lower bound there is -4. And the upper bound is 0.5. And again, we have a point that uses each of those y-coordinates, so those should get brackets. Good there? Okay. So I'm going to erase those marks so that we're doing a lot of things here, and I don't want it to get overwhelming. Domenico, did you check in at the office?
Yeah.
Okay. Thank you. So I see just one positive part here. It's just this little part is the only part that's above the x-axis. That's what positive means. So that positive section begins at the point 4, 0 and ends at the point 6, 0. So I can write that with one interval. And then I have to look at those endpoints. So is the point 4, 0 above the x-axis? It's not. It's on the x-axis. So if I'm doing positive, that 0.40 should not be classified with the positive stuff. So it gets a parenthesis. And similarly, the 6 should get a parenthesis. Okay with that? Next, let's find the negative stuff. The negative parts are below the x-axis. So all of this is negative, right? Now, you look at this and you're like, oh, that's one negative piece. It's actually two. Where's the break have to occur at? At this point right here, because that point is not below the x-axis, it's on the x-axis. So this is actually two separate negative pieces. That's a little tricky. Okay, so the first negative piece begins at -6, -3, and it ends at 0, 0. Because -6, -3 is below the x-axis, that -6 should get a bracket. But because 0, 0 is not below the x-axis, that's going to get a parenthesis. The second negative part begins at 0, 0 and ends at 4, 0. Again, 0, 0 and 4, 0 both on the x-axis, so those should both get parentheses. Everybody okay there? Now we'll do the 0 part. The 0 parts are where the graph is on the x-axis. So we have exactly 3 points where the graph is on the x-axis. Because the part that's on the x-axis is just points, it's not like a segment of the graph. I'm not going to use an interval to describe the 0 set. I'm going to use the set notation, so I'm going to use the squiggly brackets. And then I can list those x-coordinates all individually. So the difference between an interval notation and a set notation is the interval 4, 6 is all the numbers in between 4 and 6. So 4.1, 4.01, 5.7, 4.79326, everything in between. If I have the set 0, 4, it's just the number 0 and just the number 4. It's not anything in between. Is that just to kind of clear up the notation there? That's a common question. Okay, I'm going to erase all of this because I'm going to mark it up again. So next part we'll do increasing, decreasing, and constant. So I see increasing is where we're walking uphill. So I see one increasing spot there. And then I see one increasing spot there. Everybody agree with that? Okay. So this first increasing spot begins at the point -3, 3 and ends at the point 0, 0. And the increasings and decreasings and constants always get parentheses because of the way that we define what that means. But we don't need to worry about the definition. You just need to remember that for the increasing, decreasing constant, all parentheses all the time. You don't have to worry about anything else. The second part of this begins at the point 2, -4 and ends at the point 5, 0.5. So 2 to 5. And again, these all get parentheses. Now let's look at the decreasing parts. So I see one decreasing part here and another one over there. So this first decreasing part begins at the point 0, 0 and ends at the point 2, 4. So 0 to 2. And we always get parentheses there. And the second part begins at the point 5 and then 0.5 and ends at the point 6, 0. So we go 5 to 6. And then the last part is the constant section. So that's where the graph is flat. We have one flat section right there. So that begins at negative 6, 3 and ends at negative 3, 3. So negative 6 to negative 3 with parentheses. Again, increasing, decreasing constants, all the intervals all get parentheses. Joe, does that help?
Yeah.
You're welcome. As far as like a test question level of difficulty, this would be as hard as I would reasonably make a question like this for the test. They would be no harder than something like this. In all reality, it would probably be more similar to number 1 that I think was a little bit easier as there was less multiple parts going on. But this would be like kind of a maximum level of difficulty. Ben? Jacob.
Can you do, for homework number 4, can you do number 8, please?
Sure. Work 4. So it says to write the end behavior, assume that the graphs have arrows at the ends of them. Okay. So basically we're looking at something like this. So if we're just going to describe this in words, we'd say like the left arrow points down. You agree with that? So the way we say left arrow is we say X, which describes left and right. And on the number line, negative infinity is to the left. And then points down, well, up and down is the Y. And down on the Y-axis is negative infinity. So that's one of the two end behaviors, because that's how we'd write it. So that's this one. And then the other one, we'd say, well, this is the right arrow. And that also points down. You agree with that? So left and right is about the x-coordinate. And the right direction on the number line goes towards positive infinity. All the positive things are to the right. And the points down, well, y is the up and down direction. And down is where the negatives live, so it goes to negative. Does that feel okay there?
Yeah.
So again, like I think it's helpful, especially as you're starting out, to think about writing it in words and then translate the words into the symbols. But again, whatever works for you is fine, but I'm just going to show you what I think is helpful in terms of remembering what to do.
Why would for the right arrow, why would the X or the infinity be positive?
For the X,
Yeah.
because if you're going on the x-axis to the right, that's where like positive infinity lives on the x-axis, right? Just like if you're going to the left, that's where like negative infinity would live. So you have to look at both directions, the left and right and the up and down, right? Just because it's pointing down doesn't mean it's, you know what I mean?
Yeah.
That's only going to give you the y part, not the x part. Does that feel okay?
Yeah.
Okay. Cool. Good question. Again, like it's easy to describe it with words. Getting the notation squared away is probably the difficult part, but it's not so bad once you kind of get the hang of it. This notation, I think, is actually pretty intuitive because it's just left and right is x, up and down is y, and then just, like to the left is negative or down is negative, and up is positive or right is positive. And that's kind of intuitive because that's how the number line is set up, or the axes are set up. So, who's next? Yes. Yes. Can you tell me your name? Elizabeth Gruden?
Yeah.
Okay. I'm just working on names. This number 5 here that's on the same page?
No, homework 5.
Oh, homework 5. Yes, absolutely. We can do something from homework 5. Which number did you want to do?
6 or 7.
Okay. Does anybody have a preference? 6 or 7? No? Okay. Well, I'll pick whichever one I think is more interesting. Okay. Let's do 7. I think it's a little bit more complicated here. So there's 2 tools that I'm going to use to kind of do this problem. Let me check something real quick. I want to make sure that I'm using the same notation that I gave when we did this in class. Am I missing one here? I don't know. All right. What's going on here? Anyways, sorry. Okay. So what I'm going to use is I'm going to use this formula right here to pick out the values for A, H, and K. And then I'm going to use those values to create my transformation map. And then I'm going to use that transformation map to find my new points. Okay? So if we look at number 7, I want to try to write it in this form right here. So I can see that the A value is this 1.5. Okay with that, Elizabeth? Okay. That the H value is 2. Notice that the H is not -2. Why is it not -2? Because in that general form, there's a negative. It's a subtraction symbol between the X and the H, so the H is always kind of the opposite sign of what it appears. And then I should have some kind of a K here at the end, but there's nothing written at the end. So since there's nothing there, and the K is supposed to be added, I can just assume the K was 0, because if you add 0, it's the same as nothing happening. Is everybody okay there? So I have K equals 0. So now I'm going to go ahead and put those into this map. And I'm not going to bother writing the +0 at the end if that's okay with you, Elizabeth. Is everybody so far so good with how I piece this together? And now what I'm going to do is I'm going to go back to my graph and I'm going to take, oops. Okay, come on, OneNote. I'm going to take these 5 points that I've been given and use them, or use that transformation on them. So -1, 0. And then it was like -1 point or 0.15, and then -308. And what do I have here? 1, 0. And then 215 positive 308. And the last one, so those are the 5 points from my graph. Jacob?
Oh, man.
Sure. So what I'm going to do then is I'm going to take this x and y for each point and plug it into this map up here. So -1 would go in for x, and 0 would go in for y. So when I simplify that, I get the 0.10. So I'll do the next one. So I have 1.85, and then I'm going to use my calculator real quick to calculate 1.5 times 308, because I'm not confident that I can do that in my head without making an error there. At least not at 8:12 in the morning. You guys know what I mean? Yup. So then we'll do the next point. So I have 3, 0. And the next point. So these are the new points that I have. Elizabeth, are we okay to this point?
Yeah.
Okay. So now that I have these new points, I'm going to do something OneNote-y here, and I'm just going to move this up over here so I can actually see these points and the graph at the same time. So I'm just going to now plot these points. So I have 1, 0, and then 1.85 negative 4.62, and then I have 3, 0, then I have 315, and then 462. And then 5, 0. And I don't know why I wrote 415. That should, or 315. That should have been 415. My apologies. Gosh, come on now. So when I connect these, it looked like that. Does that help, Elizabeth, in terms of what to do there? So the two tools that you really needed to have were these two, right? We needed that first tool to pick out the values for A, H, and K from our equation. And then we used those values for A, H, and K to create our map. And we just applied that map to each of the points that were given to us to find the new locations. So very much like what you would have done in geometry when you transformed, like took a triangle and did a transformation on it or something. So the same kind of idea here. But if you didn't remember those two tools, it's one of those where it's like, what do I do with this? I'm not sure. But it's kind of plugging stuff into formulas. So it's not too bad if you look at it that way. Is that okay? Yes, Joe?
Okay, it's like a general question.
Sure.
Do this on loose leaf and then put it on the window. There's a lot of them.
Yeah, absolutely.
Well,
So to do that, all you would do is like take a picture of your loose leaf, right? Email that picture to yourself, and then you would just probably have to save the picture file to your hard drive, and then you can just drag the icon into OneNote.
okay.
So for example, let's see if I have a picture of something floating around here. I have some screenshots. That'll do. Okay. So I just take the icon, and if I drag it into OneNote, it just pops it right in there for me. And if it's upside down or whatever, if you right-click on it, there's rotate options or flipping options. If it's like, on the side, I see that happen a lot with kids that take a cell phone picture because they end up taking it landscape. And then when you save it, it's like on its side or whatever, and it needs to be tilted. But yeah, you can absolutely do that for your homeworks. No big deal. You don't have to do it in OneNote yourself. That's fine. Again, the goal is to make this not harder than it needs to be for you, but allows me the ability to collect the homework without actually having to collect a stack of papers and then carry a bunch of papers around trying to grade them or whatever. Makes my life much, much easier to just have it all in one place on the computer. But if you like working on pencil and paper, perfectly reasonable thing. And you can just take a picture when you're done and drop the picture into OneNote. Does that make sense?
Yep.
Okay, so it's really easy to get them in there, right? You just literally drag the icon into OneNote and it just pops it in there for you. Now keep in mind, after you do that, it's going to take a lot more time to sync. So if you, after you do something like that, make sure you right-click on your notebook and do the sync and force it to sync right then and there. Because if you just do that real quick and then close OneNote, I won't be able to see it. Right, it takes a minute for that stuff to sync up, especially a big file like a picture. And when you're taking your picture, try to make sure you use a cell phone camera because it's much, much better than your tablet camera. I probably won't be able to read your tablet camera like well enough to grade anything. So use your cell phone camera. Yeah, no problem. That was a long-winded answer to a pretty easy question, but don't hurt nothing to be super specific. Who's next? What else should we talk about? Yes. Tell me your name though, please. Raylan, thank you. Sure. Can I just pick one or the other since it's kind of the exact same thing? Okay. Should have done that because we have it already here. So This problems 1 and 2 are things that you'll do just on your graphing calculator. So I'm going to do problem number 2, but it's certainly worth running through again how to use our graphing calculator to do that. So if you want to follow along on your graphing calculator, you're welcome to do so. If you just want to sit and kind of pay attention and watch, that's okay too. Again, I record all of these things, so you can always go back to Power School and find the lecture and find this if you need to go and see the steps again. So we're going to do number 2. So I'll start by turning on my calculator, and I'm going to press the y equals button. And if there's anything in any of my y equals spaces, I'm going to get rid of that by just clearing them out, pressing the clear button. And then I'm going to type in the equation exactly as it's written on my sheet of paper. I'm going to make sure to use the negative symbol for the negative signs rather than the subtraction symbol. So negative 0.05x. And then to get the exponent, I'm going to do this little caret button here above the division sign. And I'll type in the number 4. And now if you look, my cursor is still up in the exponent. Can you see this at all? If you turn the light out, it'll be much better. You guys can, if you ever have trouble seeing the board or whatever, we're doing anything, just stand up and turn off the light. You don't have to ask. Anybody can do it. We'll never be upset about that. It's important that everybody can see. Does that make it better? Considerably, right? Yeah. So a lot of times in the morning, it's pretty dark when I get here, so I turn the lights on. But by the time first hour rolls around, there's enough light on outside that it's probably hard to see the board in some of these situations. Anyway, so I've got the cursor still in the exponent. You see how there's like an arrow on it though? If I just press the right arrow, it drops the cursor back to the main line and gets me out of the exponent. So then I have minus 0.1x to the third. So I'll do that, exponent 3. And then plus 0.8x squared. And then plus 0.1x minus 0.75. So I've just typed this in exactly as it's written. Now what I want to do is have the calculator display this graph. So for us, the easiest things to do is going to be to press the zoom button, which is right here in the middle. And we're going to pick the command Z standard. So you can scroll down to that and press enter, or you can just type the number 6 because it's the 6th command. So we have this, and my axes are turned off. I did this for another class, so I'm going to just real quick turn those back on. That's not something that would probably ever be an issue for you. But we were doing something in another class, and the axis was in the way of seeing what we need to see, so I turned it off. I'm going to turn it back on because that's really what your graph is going to look like. So if I look, I see that I have a global maximum here because that's the highest overall point. I have a local minimum here because there are points lower than that, but none in the area. And then I have a local maximum here. Again, there are higher points in this, but none in its general neighborhood. So there's 3 things I need to find. I need to find this global maximum, this local minimum, and this global maximum. So I'm going to start with this one, and then we'll find this one, and then we'll find this one, just as my general plan. Okay? So to find anything on the graph, the menu that we're going to need to go to is going to be found by going second and then the trace button. So this menu contains all the graph tools, all the functions that I can use on a graph. So the one I'm going to choose here first is this maximum command, because the first one we're going to look for was that global maximum. So I'm going to use the maximum to find a maximum. So I'll press enter. And now here the calculator is asking me some questions in the lower left-hand corner. So the first question it asks for is a left bound. And you'll notice that I also have a cursor flashing on my screen now. So all I need to do is move that cursor using my left or right arrows so that it's on the left side of that maximum that I'm looking for. Does it matter where on the left side it is? No. So like where it's at right now is fine, or I could have pressed left again and it's fine, again and a fine, still fine, doesn't matter. So press enter. Now it changes the question. It asks for a right bound. So now I just need to move it somewhere to the right of the maximum I'm looking for. Anywhere to the right will do. That looks fine to me. I'll press enter. And then a guess. You don't have to move it for the guess, just guess wherever you're at. It won't make a difference. Well, I should say it won't really make a difference. And then it spits out my point. So this point is -365, yada, yada, yada. Well, let's go 3 decimal places. 653, and then 5.531. So I'll write those down. So I have, for this, I have a global max at -3.653, comma, 5.531. So far, so good, Raylan? Okay. Next up is this local minimum here. So I'll press second and trace. And this time I'll go down and select the minimum command or press the number 3. And it asks me the same series of 3 questions. So I'll move it so that my cursor is on the left side of that minimum where it is. Looks good. And then it asks for right bound, so I need to move it on the right side. Now here I need to be a little bit careful because I can't pick a point that's lower than that local minimum I'm looking for. But as long as you pick something kind of over here, you're going to be in good shape. So right now I can tell I'm to the right of the bottom. Even here I'm okay, so I'll just press enter. And the guess doesn't matter, doesn't really matter, just pick wherever you're at. So there's my local minimum. So rounded to 3 decimal places, I have -0.062 and then -0.753. And then I have one more local maximum to find. That's right there. So second and trace. Pick the maximum command this time. Left bound. Well, currently where my cursor is at is left of this maximum. So I'll use that one right now. And then for right bound, I'm just going to move this over to the right of that maximum. So that looks good. And then guess, I'll just use wherever I'm at. So my local maximum then is 2.215, 1.106. Does that feel okay? So the calculator is going to do most of the work there for us. We just have to remember how to ask the calculator to find those points. The only thing that we really have to use any mathematics for is just visually identifying, like, is this a maximum or minimum and whether it's local or global, which is not terribly difficult, right? Because you're just using your eyes and looking at a picture. There's nothing to compute, which is nice. The calculator does all the computation for us. We just have to remember, like, where the menus are and like what the commands are called and like how to use the commands, which is something, right? Like you need to, but you practice it once or twice and it's usually not too bad. Okay. Of course. So I'll make that big again. Okay. Who's next? Yes. What is your name? Megan Basili. Yes. I ask you this every time you raise your hand, and eventually I'm going to remember, Megan.
So on the
Yeah, sure. Let's look at that. Ah. Okay. Okay. So how do we find the domain and range for 6? So let's start with the domain. This is a little tricky because what we're given is an equation rather than a graph or a set of ordered pairs or a mapping diagram where it's a little bit easier to kind of figure out the domain and range, right? When you're given the equation, it's maybe a little bit tougher. So what I'm going to think about here for the domain, and we have to do the domain first for a problem like this, is I'm going to think about what values of x could make this undefined. So do you know what I mean when I say undefined? Kind of. Okay. What's an example of a math problem that results in an answer that's undefined? So pi is a number. That's okay. It's an irrational number, but that's fine. That's a reasonable answer. Okay. So there's two situations that you guys have seen that can cause something to be undefined. One of them involves 0, but there's an operation that we can do that if 0 is involved, we get into trouble with. Dividing by 0. Okay, so is there any way that if we plug in a value for x, we would end up dividing by 0? For this problem's number 6. So is there any value that if I plugged in for x would result in me dividing by 0? No, right? That's a nonsense question. There's not even any division going on in the equation for number 6, right? So that can't possibly happen. So far we've cleared that. So there's no x's that can get us in trouble because they end up making us divide by 0. Okay? The other instance involves square roots. What can we get in trouble for involving a square root? If it's negative, right? So if we square root a negative number, that also causes or results in an undefined answer. Plugging in a value for x, could I ever get a square root of a negative here? No, right? There's not even a square root in this problem. So is there any way for a value of x to make this undefined? If I have only 2 causes that we know about, and neither, like no value of x can cause one of those 2 things to happen, well, that just tells me then that I can pick any value for x and this is going to be fine. It'll give me an answer. Megan, does that feel okay? So there's no value of x that would not result in an answer, right? If you say, oh, what if x is 7? You plug 7 in, I get an answer, right? What if x is -3? Well, if I plug -3 in for x, I get an answer, right? And no matter what value of x you pick, you're always going to get an answer to this. It's never going to make this equation undefined because there's no way that we can end up dividing by 0 or having to square root a negative. So because I can't do any of those things, then any value of x is fine. So we just describe the domain as everything, negative infinity to positive. We'll do an example here once we're done with 6 of one where that's not the case, okay? Just to kind of show you what that might look like, because I can tell you're not quite sure, and that's okay. We'll do another example here in a second to kind of help you show the difference, okay?
So basically, if those two don't work, it can be any number of x.
Yes, yes, that's what we're saying. I mean, eventually that won't be the case, but for right now, that's what we're saying, yes. And in fact, in this class, we'll run into some stuff that also that causes, could make it undefined. Yeah, Kalila? Kalila, sorry. Yes, of course. Okay, so we've kind of struggled through the range here, or the domain here. Let's do the range. We need to do the domain first in order to do the range, because we have to know like what values of x we can plug in, because the range is about what values of y we can get. Right? So we have to know what we can plug in to know what we could get back. So if I plug in a, so let's think about the smallest y value we could get back, okay? If I plug in a really big or a really small value for x, like negative infinity, I'm going to get negative infinity back for a y because I have negative infinity minus 1. There's a plus 1, and there's also a minus 1, right? So I can get as small of a y value as I want. Does that make sense? Okay. So like if I pick x to be like negative, like 1 million or something. If I do negative 1 million plus or minus 1, well, that gives me negative 1,000,001 and then negative 999,000. But the fact of the matter is I'm getting a y value that's smaller than the x value that I chose, right? That's what I'm mostly concerned with right here. Is that okay, Megan? Now do you kind of see what I'm saying? Okay, I couldn't really, you trailed off a little and the mask made it hard to hear, and I really want to try to do a good job of answering this for you. Can you repeat that? Okay, so what matters is, or what I'm mostly caring about here, is that the y value I'm getting back is smaller than the x value I put in. Right? And since I can always put in any value for x, I can get back anything smaller than that for y, right? So what should be the lower bound for my range? Still negative infinity, right? If I can pick x to be as small as I possibly can, and y is always going to give me, one of the y's is always going to be smaller than that, I can get y as small as I want it as well, right? Now let's go the opposite direction. Let's pick x as big as I possibly can. One of the y's is always going to be bigger than that. So what should the upper bound for y be? Positive infinity. So my range is also negative infinity to positive infinity. So alternatively, the other way you could have imagined this is you could think about it as a graph. So if I graph this, if I graph y equals x plus 1, it looks like this, right? If I graph y equals x minus 1, it would look like this. Is that okay with everybody? Just straight lines where the y-intercept is 1 and then negative 1. If I look at each one of these, so this is going to be the graph of both of them. So this is going to give us this graph. It's going to give us both parts. So for each x value, you're getting two y values, right? So you have these two sets of lines. Everybody okay with that idea? Just as a graph? So I could also figure out the domain and range by looking at this graph, right? So I have an arrow on the left side and the arrow on the right. So I can get my x's go from negative infinity to positive infinity because the arrows are connected there. Does it matter that there's a second set of arrows going left and right? No. It's fine. Similarly, I have an arrow pointing down and an arrow pointing up that are connected. So I can get all the y's. Does it matter that there's a second set of arrows? No, because I have all the y's already with the first graph, or the first line. The second line doesn't even really matter, at least for the domain and range. Does that feel okay as another way of kind of looking at it? Good. So I had promised you we'll do another example of something that like could be undefined, or whose domain wasn't just going to be all real numbers. So what if we have an equation like this? And this is far harder than anything I would give you on a test. Okay. So when I look at this, I see two parts that could get me in trouble. I see a place where the denominator could be 0. Yes, sir. Of course. And I see a place where I could end up square rooting a negative. So I'm going to make sure that I set the denominator not equal to 0. And I'm going to set the stuff under the square root to be greater than or equal to 0. Right? Because I know that if I divide by 0, that's going to be a problem. Or if I square root a negative, that's going to be a problem. So the thing in the denominator has to be non-zero, and the stuff underneath the square root has to be non-negative. Is that okay? So I can just like subtract 1 from both sides. So I have my domain has to meet these two criteria. Now, it's not obvious maybe how to put those two things together. So what I think the easiest way to think about something like this is to use like the number line. And I'm going to graph each of these two on the number line and then look at their overlap. So if I graph x is not equal to 0, that's just going to look like this. It's going to be everything except for 0, where I have the little open circle. And then for the other one, x is greater than or equal to -1. So I have filled in circle at -1, and then an arrow going to the right. Now, if I look at the overlap between those two, I have those two parts overlap, and then those two parts overlap. Is that okay so far? So this part begins at -1. It includes -1, so we'll have a bracket. And it ends at 0, but it doesn't include 0. So I have a parenthesis there. And then this second part starts at 0 and goes to positive infinity. And again, doesn't include 0. So this would be like the domain for that one. So for the domain to not be all real numbers, you either need an x in the denominator or you need an x under a square root symbol. If you don't see those two things, the domain is just going to be negative infinity to positive. Like this? Right now? No. By the end of the year? Yeah. But I wanted to give you an example of like, what would it need to look like if the domain isn't all real numbers, right? Just negative infinity to positive infinity. Like we talked about ways that it would become undefined. I wanted to give you an example where that could happen. And this is a pretty complicated example, but like not a trivial one. Correct, yeah. I mean, we can see that real easily when we get to if we were able to get to the graph, because that's going to fail the heck out of a vertical line test, right? And in fact, any x you pick, you're going to get two y values for that same x, right? Similar to what we did here. When I picked x to be negative 1 million, I got two y values for that 1x, which is, again, that's a no-no for a function. So either one of these two would be a reasonable justification for y. Picking a value for x and showing you get two y's, or drawing the graph and showing it fails a vertical line test. Both of those are excellent justifications. So this was a good one to talk about, Megan, as it was kind of tricky and there's a lot going on. It was in a form that maybe we're not the most comfortable with dealing with, because it's a little bit more we have to use, you know, like just kind of being clever, right? There's not just like, oh, we know it every time because we just look for this. It's like, well, maybe not. Is better? Okay. If you want to do more, we can do more. It's okay? Okay. I reserve you the right for you to change your mind later if you decide, like, yeah, I do want to see some more. So you can change your mind later. I just want to let you know it's not forever. Okay? What else? These are really good questions, guys. I appreciate kind of the detail and like the wanting to search out, like, okay, so what am I really looking for here beyond this specific problem? You guys are doing a nice job of kind of thinking generally on what am I really needing to look for? What do I really need to do? You know, that's exactly the way you want to be thinking about mathematics. Is you don't want to remember it as a bunch of like hyper-specific problems. You want to look for like the general trends and the general setup. Makes your life much, much easier if you're able to think about things that way. Joe.
So for number 5 on the chapter 1 review,
Yeah.
just the like domain and range, just like figuring out if it's a function or not. So if the domain, if it branches off into 2 ranges, is that a function or not?
Okay. So if we're looking at number 5, and we're trying to decide if it's a function or not, the only thing we care about is what's happening to the x's. So for example, this right here implies that we have the point 1, 2 from this arrow, and we also have the point 1, 4 from that arrow. Here we have an x coordinate that's used twice, right? So this is not a function. Okay. Now, does it matter that some of these y's get used by more than one x? No. Not when we're determining if something's a function or not. There's actually another property that we haven't talked about yet that we will later this year. I don't remember if it's first semester or second semester. Where the number of x's that are paired to the y matters, but we haven't talked about that yet. And those are still functions. So, is that cool?
Yeah, thank you.
Yeah. Again, like these kind of clarifications of what we're looking for to make that determination. These are good questions. They're important questions, right? When it comes to doing the test in a timely fashion, it's nice to like, okay, I know what all these definitions are, but what do I really just need to look for when I'm looking at this thing so I can take it and do this in 30 seconds instead of sitting there and thinking about it for 5 minutes, right? You'd like to take and save up your thinking about it time for the questions that are like, I actually kind of need to think about this, versus the ones that are, you know, have a quick way of doing them. You know what I mean? Oh, excuse me. I got a case of the sleepies. They seem to correspond with Fridays a lot. Anybody else? Okay. Let's talk a little bit about the test format then for you guys to give you an idea of like what the test will look like. Maybe help your study preparations or whatever. Does that sound good? Okay. So I'm going to stop the recording right now because I'm going to move the projection so that you guys can't see it